Hello, everyone. Okay, in the previous video lecture, as we were discussing how to implement DPI and service awareness, I got to realize that maybe the examples given were too random and maybe you won't be able to understand. So what I did is that I created some new configuration examples, and I think we would be better be able to correlate these uh, but as we go down towards linking each and everything as per the initial that diagram of DPI I showed you. Okay. So we have a very simple example that we are going to start off with this specific IP address. Okay. So the first thing is that I'm going to create a new filter. The filter's name is filter test. The IP address for which the filter is being created is this one. And since it's a single IP address, so my mask is going to be 32. And the start and the end port, like this filter is applicable for each and every port corresponding with this IP address. Okay, the L34 protocol is any, right? In case you get an IP address that is in a sequence, like it's in the form of a subnet, in that case, you can mention an IP address and then you can calculate its mask and then mention. So it will be for more than one IP address. But if you get a request to create a rule for multiple IP address that do not have any correlation, so you'll have to create new filters. So filter test one, filter test two for the other IP, filter test three for the other IP. So once all your filters have been defined, you are going to add this filter to a single filter group. So this filter group test is contains filter test, and if any other filters, if I have multiple IPs, I'm going to add all those filters into this. So these are going to be mapped under a single filter group. Next, since a filter group is mapped to a filter flow, a flow filter. So the next command is to add a flow filter, and here I'm adding this filter group test to this flow filter. So its name is filter flow filter test. Next, this is an example if I need to perform any blocking. For example, my requirement was that if any MSISDN initiates a session with this IP address, so if a session is initiated via the user equipment, the UE, it should be discarded. But if this server tries to communicate with the UE, it should allow. So in that case, the app action, the group and the action property name is a unique name. And here what I mentioned is that if it's up initiated, yeah, if it is uplink initiated, the UE initiated, so both uplink and downlink are discarded. But if it is DN initiated, like it is PDN initiated, then it's uplink and downlink should be passed. So this is just an example. We can create accordingly. I mean, if we want to block every service or need to allow some specific service, so this is an optional thing that we can do. The next is to create a CVB ID. So my unique CVB ID is CVB test underscore blocking because we are talking about blocking some service. So blocking and its charging mode is offline. So this CVB ID, like I mentioned before, we need to define two different sets of CVB ID, one for offline charging, one for online charging. So this one is for offline charging. Its rating group is 11, its SID is 20, and its metering type is volume. And then a similar CVB ID for online charging. Here, the only difference is the name of the CVB ID and the charging mode is online. Next, we need to combine all of these CVB ID into one charge property name. So my charge property name is something unique, CP underscore test underscore blocking. And here, I'm going to add both the offline CVB ID, which is the uplink CVB ID and downlink CVB ID offline, and the online uplink CVB ID and downlink CVB ID being uh, are being mapped onto this single charge property. Next is your PCC policy group, which basically combines your action property and your charge property. So my PCC policy group is CG underscore test underscore blocking. Here the charge property is the one which I've defined above, CP underscore, and action property is going to be AP test blocking. Okay, so my PCC policy group is now created. Next, I need to add a rule. So my rule name is r_block_test. And here the policy type is going to be PCC. There's another policy type which is used for header enrichment. I'll quote an example of that just shortly, but here it is PCC. The filtering mode can be filter group, it can be filter, it can be flow filter. So here the filtering mode is flow filter. So I have mentioned the name of the flow filter, which I have mentioned here, ff_test. The priority, obviously, as I mentioned, there can be multiple rules which can be triggered because of one specific condition. So need to specify the priority of the rule, and then the policy name, which we recently created, and then the priority of the policy name as well. Okay. Next is to add a new user profile. So this command is very simple: add user profile, the profile name, and it should be a unique profile name. Next is to bind this rule to this user profile. So add rule binding, the user profile name uptest, and R block has this new rule that I've created. I am binding it to user profile. Next, I to create a new user profile group. This command is simple: add user profile group, and then you map your user profile to a user profile group. So this single user profile group can have multiple profiles. For example, I create this rule, I map it to this user profile, I create another rule, I can map it to the same user profile. And maybe I have rule 3 and rule 4, which are being mapped into user profile 2. So both of these user profile are going to be mapped into a single user profile group because the user profile group and the APN correlation is 1 to 1. One APN cannot have multiple user profile groups. So the next thing is to map the APN to the user profile group. So if my APN is this, I'm going to map it to the user profile group. So any user that brings in uh, um, any user that is selecting this APN and it is allowed this service, this user profile group is going to be hit. And from this user profile group, the GGSN is going to identify that, okay, this is the user profile. And from this user profile, it is going to identify, okay, this is the rule name. From this rule name, it is going to identify, okay, this is the CG, this is the policy name. And from this policy name, it is going to identify that, okay, how I'm going to charge it and how am I going to basically apply any actions to it if it is required. Right? So this is basically how you create different user profiles and how you correlate starting from the flow filter, start from the filter and ending up to binding the APN to the user profile group. Next is an example of header enrichment. Header enrichment is where you need to add some specific prefix into the header of the request. So here our requirement is to add an MSISDN to the request that is being sent to a specific server or URL. Right. So you need to add the MSISDN to any incoming request. So you create a header name by the name of header default. It can be any name. And the prefix you specify is the MSISDN, and the header type that need to be inserted is MSISDN. You can insert numerous information in header enrichment. You can add IMSI, MSISD, and IMEI, and there is a list of information which you can get from edX, where you can add this information as part of header enrichment. Next, you add a flow filter. So we create a new flow filter by the name of header default, and that is basically bound to the filter group name fg_test, which we already created. So what it means is that any request that is going towards this specific IP address that we have mentioned, 82.39. Header enrichment is going to be done for the requests which are going towards this server IP. So any request initiated from the handset will come to the GGSN, and it will add its MSISDN in its header, and then it is going to close that packet and it is going to send that packet towards that specific destination. And in case we need to do header enrichment for a for any L7 filter name, so we can find it towards any L7 filter which we have created. Like this is an L7 filter for Vimeo URL. So any request that is going toward Vimeo, uh, its request is going to be appended with the MSLDN. So we using add protocol bind flow, the flow filter name remains the same, and this same flow filter will have this L7 filter along with the specific protocol name appended to it. So any request that is going towards this FG underscore test IP address, or any request that is going towards this L7 filter of Vimeo URL, that is going to be appended with this MSLDN. Next part is to basically bind, is to create a new rule, a rule for header enrichment. And here you can see the policy type of head N. Like in previous rule, the policy type was PCC. So we were basically binding this policy name to this rule. Here, the policy type is header enrichment. So its flow filter remains the same. But here the policy name is going to be header underscore default, which is mentioned here. And obviously we add a priority to it so that there are multiple rules for the rule with the highest priority is going to take effect. Next, we are going to bind this user profile, the existing user profile with this specific rule name. So this rule name which we created, we are going to bind it to this user profile, and the user profile is going to be created, and this user profile group, obviously, if it doesn't exist, then the user profile group needs to be bind to the user profile, and then user profile group gets binded to your APN. So if we combine both of these configurations, then this user profile test has a PCC policy. This one is the PCC policy, which indicates how to charge the packet, and which indicates whether any action needs to be applied on this packet. And it also contains a header enrichment policy, which indicates that any incoming packet will be appended to the MSSDN that is bringing in that packet. And then that is going to be served to that specific IP address or the specific URL. So this is how the configuration of header enrichment is done. Next is how to create a flow filter for L7 rule. This is something which I quoted earlier, L7F underscore Vimeo over here. So basically the main thing how it works is like this. So in case you get some IP addresses for which you need to create a rule, so you have simple add filter command. But if you need to create rule for some specific URL, in that case, you need to create an L7 flow filter. So its command is L7 flow filter. Its L7 filter name can be anything unique. Its sub L7 filter name can be the same L7 filter name. Here you mention the URL for which you are creating this L7 filter. And then its method type you can specify based on whatever is requirement of your end client. Next is to add a flow filter. And in this flow filter, you create a new flow filter and you bind this flow filter with the filter group name, which is earlier created with this specific L7 filter. Next is to bind multiple protocols into one protocol group. If you remember in L7 filter, then we create an L7 filter, we need to bind it with the protocol and we need to bind it with the protocol group name as well. So if this URL filter needs to work with multiple protocols. So we have an internet messaging protocol, we have HTTP protocol, we have HTTPS protocol. So all these protocols are being merged into a common protocol group name by the name of PG_PMU. Next, we are going to bind this protocol group with the flow filter. So this protocol group name which we created is being binded to this flow filter, and we bind the protocol, a specific protocol with this flow filter as well. So this flow filter is being bind with this L7 filter name for this specific protocol name. So these two are being differentiated. It's a similar command, but I've highlighted G in red that this is for protocol group binding, and this is simple for protocol binding. Next is to add a rule. So a simple rule, we create a simple rule. Its policy type is going to be PCC. Its flow filter name is going to be the same flow filter which we created here. Its priority we assign, and we assign a policy name to it, that which policy is going to be applicable to it, uh, by which it is going to be charged, and by which any specific action needs, if applicable, is going to be uh, uh, applied to it. The rest of the part remains the same. Your once you have a rule added, you're going to bind the rule to the user profile, profile to the profile group, and profile group to the APM. So this is an example of how your L7 flow filters are created and your L7 rules are created. Next is an example of ACL, access control list configuration. This is very frequently asked that how to block some specific IP communication towards some specific IP. So this is an example of how to block M2M communication. For example, in most of the operators, we do not allow any mobile to directly communicate with another mobile via EGSN. You need to communicate via some third party, some voice over IP application or messaging application. Okay, so direct communication between a private IP address with another private IP address is blocked, and this is how it's done. So you add a filter, name any filter, and here you specify the MSIP mode is IP, and then you specify what is the source IP address. So source IP address we've mentioned it's 10.0.0 because every operator has the private IP addresses that start with 10. So we have mentioned that all IP addresses that are starting with 10, and the server IP address is also the same, 10. So any 10 segment IP address should not be able to communicate with another 10 segment IP address. So here its mask length is 8, its mask length is also 8, and each and every port, sorry, the mask length is here, and each and every port starting from 0 to 65535. So choosing this filter, we have specified that any communication between this segment of IP address to this segment of IP address is barred. Next, we add an ACL node. So an ACL node name is a unique name, and we bind this ACL node name to this filter, and we specified the action type is a gate, and the gate action is what? It is discard. So any request that is originating with 10 IP address and its destination is a 10 IP address, it is going to be discarded. Next, we define an ACL. This is a unique ACL name. And next, we bind this ACL name to the ACL node name. So here we have an ACL name, and here is the ACL node name. So the purpose of this is that you can have multiple ACL node names, and that can be bind to a single ACL. Because like user profile group, only one ACL can, only the ACL can bind to your APN. Your ACL node name cannot bind to your APN. So you create multiple ACL node names that can have multiple filters assigned to it, multiple actions assigned to it, and then you can map that into a single ACL name. And then this single ACL name is required to be bind to the APN. If you do not bind it to the APN, your ACL names are going to work. And here you have the option of mentioning in which direction this should work. So here the direction is uplink incoming, which means that any request that is originated from MSISDN is an uplink, and incoming means that it is coming towards your UGW, that is going to be blocked. So any communication from UGW onwards will not be blocked, and or any communication that is coming towards from PDN towards UGW is not going to be blocked. So you have the option of mentioning the direction. And along with this, I have also added one more script that if you have done this blocking, but you require once communication between unspecific IP address, like any source IP address starting with 10 should communicate with just one IP address. There is a private IP address within your network in which you need the users to communicate with. So you can consider this to be an exception. You can add an exception. So how to add it? You add another filter, unique filter name, and here you are going to mention that the server IP address, you will specify that one specific IP address or multiple IP address. If it's multiple IP addresses, then maybe you need to add multiple filters. Here I've mentioned just one IP address with the mask length of 32. And start and end port is going to be 06556. So this IP has been represented by this filter. And here I'm going to add it to an ACL node name, a new ACL node name, where the filters bind to it. And here I'm going to mention that the gate action is passed. So any IP that is any request that is going towards this specific IP address will be allowed, and which is going to be towards any other IP address is going to be blocked. And then I'm going to bind this ACL node name to the existing ACL name. How it is going to differentiate is based on this priority. This ACL has less priority and this one has more priority, so this has more preference. So any incoming packet, it is first going to say, okay, if the destination is this one, then this ACL and this gate action is going to be take effect. If it does not lie in this range, then it is going towards this one. And here is going to see that it is to be discarded, and then it is going to be discarded. If this priority is higher than this, then this exception is not going to work. Okay, this brings us to the conclusion of deep packet inspection and service awareness. I hope you guys got to learn and understand how service awareness works, how the basic level configuration is done, how the basic level of DPI configuration is done. I have also added some examples of ACL, how to configure L7 filter, how to do blocking and all that. So I hope that this will be a fruitful session for you, and you can gain some more insight into PS4. And what I would recommend you is to go through your configuration files of your GGSN and see that how DPI is done over there, how different rules are defined, how different filters are defined, and how different ACLs are defined. So you'll get a better understanding. If you match those configuration with this, then you'll get a better understanding of how packet core is being running, and specifically how service awareness has been running in your work. Okay, thank you. Have a nice day.